to task 4. So you've got a pulley belt, has a diameter of 300 millimeters and is turning at 2,700 divided by pi revolutions per minute. Find the angular velocity of the pulley and the linear velocity of the belt, assuming that no slip occurs. So this might be worth drawing out. It's this sort of situation, isn't it? We've got some sort of rotating wheel, and then associated with that is also some sort of belt attached to it. Symbols, if you're going to put symbols on these things, omega, not W, omega for the angular velocity and V for the linear velocity are recognized symbols. Anybody know a formula that might be useful? Yeah. Yeah. Any other formula that might be useful? There's one in particular that relates angular velocity to linear velocity. And that is that V equals omega R. So if I know the radius of rotation of this thing, then there's a direct relationship between the angular velocity and the linear velocity. So that might well be a useful formula. Radius. So I then might be tempted to write down what I know. What do I know? Well, yeah, but I don't know the radius directly, do I? What I do know is the diameter is 300 millimeters. What else do I know? Where does it tell me that? I know that 2,700 over pi revolutions per minute is the rate at which it's turning. What's the word for that? RPM is the unit for what quantity? When I talk about RPM, what am I talking about? Right, the rate at which it's rotating, the number of rotations per second, what's the word for that? No. No, that's the speed. It's the frequency. 2,700 over pi revolutions per minute. That's the frequency. Anything else I know? No, that's it, isn't it? Oh, true. Yeah, you could work out. So, but that brings us neatly to what's the next thing? Are these convenient units? Sorry, Mark. What were you going to say? Omega formula. Yeah. Is that what you? Yes. There is a. That might well be useful. There's a formula that relates the angular velocity and the frequency. 2 pi f. Yes, Mark. So that's going to be useful. Are these inconvenient units? What might you do about them? Meters might be useful, and per second, yeah. So we've got to do some work around the units. We're not told the radius, we're told the diameter, and there are some formula that might come in useful, okay? And you've got to find the linear velocity effectively and the angular velocity, haven't you? Angular velocity and linear velocity. So I think that's probably doable. Again, you'll see lots of examples in the text, and we have looked at some examples. Okay? Any other questions on this?